11.7 Factoring ax squared plus bx plus c, day 3. Today we're going to be looking at our special products. If we recall back to multiplying, if we multiplied these two together, I would have x times x is x squared, x times 5 is 5x, negative 5 times x is negative 5x. Notice our middle terms here cancel. Negative 5 and positive 5 cancel to 0. And then negative 5 times 5 is negative 25. This first one here was our difference of two squares. If we had the same exact terms, x and 5, with opposite signs, that was the difference of two squares. The final answer was x squared minus 25. The first term squared minus the second term squared. These are also, we're going to talk about, are called conjugates. Conjugates are two factors that have the same exact numbers here but opposite signs. So that's when we have our A the same, our B the same, but opposite signs. Alright, for our second one, we can remember the pattern that we had done for this one, or the x plus 6 squared means x plus 6 times x plus 6, and we multiplied that out. So x times x is x squared, x times 6 is 6x, 6 times x is 6x. Both of them are positive 6, so adding them together to get 12x, and 6 times 6 is 36. This one is our perfect square trinomial. This one will happen a little more naturally, but I'll show you how we're going to write our answer once we factor it. Okay, getting started with our first one, difference of two squares. So our difference of two squares, a squared minus b squared, we will factor to the conjugates a plus b and a minus b. But notice that this is the difference of two squares. This only works with differences. If I have a plus sign there, this will not factor like that. Also, A has to be a perfect square and B has to be a perfect square. So let's look at our first example. Y squared minus 9. Looking at y squared, this is a perfect square. Y times y. Looking at 9, this is a perfect square. 3 times 3. So we have a perfect square in the first term, perfect square on the second term, and this is a subtraction, the difference of two squares. So once we have this, we can write our answer, factored out, y times y, and 3 times 3. The sign that goes in between them is the fact that they're conjugates. One will be plus and one will be minus. And we can see if we multiplied this back out, y times y is y squared, y times negative 3 is negative 3y, positive 3 times y is positive 3y, and 3 times negative 3 is negative 9. My middle terms, canceling out, y squared minus 9 multiplies back to my original. So this is my factored. Alright, let's look at number 2. 4x squared minus 25. Checking first if the terms are perfect squares. Well, here we have 4x squared. 4 is a perfect square, and so is x squared. So this is 2x times 2x. Notice the 4, square root of 4 is 2, square root of x squared is x. And 25 is a perfect square, 5 times 5. So we have perfect squares on both sides, and this is the difference. So this is the difference of two squares. I'll write my solution with 2x and 5, 2x and 5 with opposite signs. And I'm factored out. All right, number 3, 64 p squared minus 16. Now notice here, 64 p squared and 16 are perfect squares. However, this one has a GCF. We must always factor out GCF first no matter what type of factoring that we're doing. So between 64 and 16, they both have a GCF of 16. So I'm going to factor out my 16, leaving behind 4p squared minus 1. But notice here, I also have a difference of two squares. 4p squared is 2p times 2p, and 1 is also a perfect square, 1 times 1. Both of them are perfect squares, and we still have a difference. So my GCF comes first, and then I have 2p plus 1 and 2p minus 1. This is fully factored. Notice if you would have factored this out as the difference of two squares, square root of 64p squared is 8p. Square of 16 was 4. 8p plus 4, 8p minus 4. Notice these both have a GCF of 4. So I could factor that out at the end because my GCF of 4 and 4 gives me a total GCF of 16. But it's much easier to factor out in the beginning. Okay, number 4. 3m squared minus 48. These are not perfect squares, but they do have a GCF. The GCF between 3m squared and 48 is 3. So this leaves behind m squared minus 16. Okay, pause the video and try factoring this one out. All right, m squared minus 16 factored out to m plus 4 times m minus 4. The 3 still sits on the outside, and you can have these in different orders. The plus does not have to go first. Remember, multiplication is commutative. Okay, our next one is our perfect square trinomials. This one here, we have our a squared plus 2ab plus b squared was our a plus b squared, and same with our subtraction. But this one falls a little more naturally. So my first problem is x squared plus 6x plus 9. Now we notice here my a term is 1. This one makes us happy because these were our easy ones to factor. So all we have to do is figure out what multiplies to 9 but adds to positive 6. Well, my factors first, since this is 1x squared, I know it's x times x. And then I've got to think about my factors of 9. 1 and 9, 3 and 3. 3 and 3 multiply to 9 but add to positive 6. So we have plus 3 and plus 3. Now we can see this is working out. X times x is x squared. X times 3x is 3x. 3 times x is 3x, which gives us 6x. And 3 times 3 is 9. Now what we do with this after we factor it is how we write our answer. X plus 3 times x plus 3 is rewritten as x plus 3 squared. So anytime you factor the square of a perfect square binomial, perfect square trinomial, we write it as the square of a binomial. Okay, number 2, 49x squared plus 14x plus 1. Try factoring this one out. Pause the video. Okay, so for our c term, we only have the option of 1 times 1. But our a term, it looks kind of scary being a bigger number, but our only options are 1 times 49 and 7 times 7. Well, if this isn't our perfect square trinomial, let's try 7 and 7. So notice here, 7x plus 1, 7x plus 1 gives me 49x squared, 7x and 7x gives me positive 14x, and 1 times 1 is 1. So my final answer is 7x plus 1 squared. Okay, so let's get some practice in with these. Your first problem is 9x squared minus 64. Pause the video and try factoring this one out. Okay, let's check our work. I noticed here this was a subtraction of two terms. So I checked to see if I had the difference of two squares. 9x squared is 3x times 3x, and 64 is 8 times 8. So both of these were perfect squares. And once again, I had subtraction. So I can rewrite this as 3x plus 8 times 3x minus 8. Notice here our answer, we must have both of these written because they are not the same thing. So 3x plus 8 times 3x minus 8. Okay, number 2. 4x squared plus 20x plus 25. Pause the video and try this one out. Okay, for this one, I listed my options. 4 was 4 times 1 and 2 times 2. 25 was 1 times 25 or 5 times 5. So I checked this one to see if it was my perfect square trinomial, which it was. 2x plus 5, 2x plus 5, which I can rewrite, since those are the same exact binomials, as 2x plus 5 squared. Make sure you're writing your final answer as a binomial squared when we have a perfect square trinomial. Okay, number 3. 2x squared plus 8x plus 8. Don't forget to check for GCF first. Pause the video and try this one out. Alright, so noticing between my three terms that they all had a 2 in common. So I factored out my 2 to end up with 2 times x squared plus 4x plus 4. Next, I went to go check this was an a term equal to 1. What multiplied to 4 and added to 4 was 2 and 2. So I wrote my answer as 2 times x plus 2 times x plus 2, which was the same binomial. So we write our final answer as 2 times x plus 2 quantity squared. Okay, number 4, 3y squared minus 75. Once again, don't forget to check for GCF. Pause the video and try it out. Okay, looking at these terms, they have a 3 in common. So I factored a 3 out of my binomial to end up with 3y squared minus 25. Then I noticed I had a subtraction sign between two terms. So maybe I have the difference of two squares. Well, the y squared is y times y, and 25 is 5 times 5. So I do have the difference of two perfect squares. So my final answer reads 3 times y plus 5 times y minus 5. All right, number 5. X squared plus 25. Pause the video and try this one out. Okay, for this one, I notice I had two perfect squares here. X squared, I have x times x, and 25, I had 5 times 5. So I have two perfect squares. Then I checked my middle sign. This one is a plus sign and is not the difference of two squares. So we cannot factor this one any further. It doesn't have a GCF, and it doesn't have the difference of two squares. So this one is prime trinomial, and it is already fully factored. Okay, number 6. 12x squared minus 12x plus 3. Pause the video and try this one out. Alright, hopefully the first thing you noticed was a GCF of 3. If you didn't notice the GCF of 3, check your answer to see if you still have a GCF in your solution. Okay, so if you did factor out your GCF of 3, your next trinomial would have read 3 times 4x squared minus 4x plus 1. And then I noticed my first term was 4, so my options were 4 times 1 and 2 times 2. My options for 1 are just 1 times 1. This factored out to 3 times 2x minus 1, 2x minus 1, which this is a perfect square trinomial, so I can write this as a square of a binomial. My final answer is 3 times 2x minus 1 quantity squared. All right, be ready for some more practice.